In this video, I'll be telling you a little bit about two-way tables. Now, two-way tables they're kind of frequency tables, really. Well, they actually are. Frequency tables that you might be used to before two-way tables, though, record frequencies in a single column because they're recording data only on a single variable. Now, a two-way table extends that and allows you to write down frequencies and frequency data for situations where you're collecting data on two variables. And instead of just having a column of frequencies, we have a grid or a table, if you like, of frequencies, and hence we call them two-way tables, across and down being the two ways. Okay, so on this screen, what you can see there up on the top left, there's actually an example of a two-way table, and I'll come back to that in a moment. I'll just talk about a couple of things first over on the right though. So just to summarise, a two-way table is a way of showing data about two characteristics, or two variables, if you like, of some population or sample. They allow us to investigate associations between those characteristics. So they allow us to think about whether two variables might be related or whether there's independence in the situation. And we can do things like calculate percentages or probabilities, if you like, by row, by column, and by total. And we'll see some of that when we do an example in a moment. So just taking a look at the example that I've drawn already here on the top left, you can see it's pretty clear that we've got a table, okay, and it extends a little bit. I'll explain why in a moment. Now this table is looking at two characteristics or two variables, okay, and I would probably summarize those as being variables about age, and it looks like we've grouped age here, 18 to 30, 31 to 65, and on the top we can see coffee and tea. So I think this might be about the preferences of drinks that people would have. So for example, as you can see in blue here, 31 to 65 year olds who prefer coffee, you can see there's 9 of those, 31 to 65 and coffee. And you might look at another example, 18 to 30 year old tea drinkers, there's 6 of those. You can do the same for the other cells as well. So those are just the frequency or the counts in the sample of people who demonstrate or already reported those characteristics. Now looking at these cells that are in the dotted box, that dotting is just the way I've done it today on this video. You don't actually need to use dots, that would normally just be a regular table. What we've got there is what's called marginal frequencies. Now this one, for example, 23, is the sum of the values above it. 14 and 9 makes 23. And that's just telling us that overall in this sample there are 23 people who prefer coffee, regardless of their age, or age is not really important to me there. Similarly, 27 people prefer to drink tea, where I don't care about the age. On the other hand, coming over to these marginal frequencies on the rows, we can see that there are 20, 14 plus 6, 18 to 30 year olds, and 30, 31 to 65 year olds, because I've got 9 who like coffee and 21 who like tea. That makes 30 altogether. Then adding down that column or across the row, we should get the same total, and that total is just the number of people or the number that makes up our sample or population. So that's pretty much what a two-way table looks like, what it's comprised of and what it's about. So let's take a look now at an example of this. Okay, so here is an example that I've prepared earlier. Now, it's a little bit of a read, so I'll just give you a quick overview first. There's a sample's been taken and there's a bit of information written in the first paragraph, and then there's 3 questions to do, which is essentially creating the table and then calculating a couple of percentages based on the information in the table. So a good idea right now would be to pause the video, have a read through this yourself, maybe see if you can do the whole question yourself. If not though, don't worry, that's what the video is for. So have a read, have a go, and then come back and you can watch me run through this myself. Okay, so what we've got, let's see, hopefully you've read the question by now. You can see we start off with, we've got 50 students surveyed, 17 education students study best at home. When I read that first sentence there, 17 education students study best at home, I can see a number, 17, and 2 statements which I think are related to the characteristics or the variables which will form our two-way table structure. So I'm just going to underline one of them there, education students. I think that one of my characteristics is going to be type of student or degree that's studied by that student. Now the other one that I see in there is that it says they study best at home. So I think that the other variable or characteristic is probably going to be where this student studies best, or where they prefer to study, if you like. So if we read on then, it says while 14 students study best on campus. And you can see that distinction there. We had best at home first, and now we've got study best on campus. So I think that those are the two options for that variable about where they study best. Reading on a little bit further, we can see that the next sentence says for business students. Now, business students, that's a different degree, so I'm going to underline that in red. That'll be one of the options in our other characteristical variable. So for business students preferred to study on campus. So again, we're back to our green underlining and talking about where the students prefer to study. So let's have a look now at turning that into a table. It's going to be a two-way table, and I've got type of student. I might put that across the top. Type of student. And I've got education students, and I've got business students. And in the green, study best at home and study best on campus. So I might put down here a preference, pref just for short. And my options there would be home and campus. Okay, so you can see the structure of the table is starting to take shape there. There we go. And we can start to fill in the values. So what have we got? We've got 17 education students, so they're going to be in this first column, the edu column, and they study best at home. So I'm going to pop them up in the top left cell, 17, while 14 study best on campus. So they'll go in the intersection of campus and education in the table. Then we're told that for business students, so I move to the business student column, preferred to study on campus. So I'm going to pop that in there. And I've kind of run out of information unless you go right back up the top where it says we had 50 students in total. So I'm going to pop that in my total section there. Okay. And then to fill out the rest of the table, we've really just got to try to infer from what is given what goes in those spots. So what I could start to do is calculate marginal frequencies where I know all the information. So if I look down the education column, I know that I must have 17 plus 14 is 31 education students. Looking across the prefer to study on campus row, 14 plus 4 gives me 18 students there. Now remembering that our marginals must add up to the total, I need to get 31 up to 50 by whatever value goes in here. So I know that that needs to be 19 students popping in there. So 31 plus 19 is 50, gives me my overall total. And it also tells me that I must have 15 business students up the top there who prefer to study at home. 15 plus 4 making 19. Now we can finish off this table in a couple of different ways, but the easiest one is probably just to go across the home study preference row, 17 plus 5 giving me 32 in total. So there we go, that's part A, that's our two-way table for the data. Notice that all the information is not always given to you in the question, and you do have to do a little bit of inferring based on what you do know. Okay, let's take a look at part B now. Part B says, what percentage of business students prefer to study at home? Seems pretty simple on the surface, but something to be very careful about is statements like this, percentage of business students. Now that tells us what we're going to need to divide by when we calculate this percentage. So it's very important to get that right. We want to know out of the business students, okay, and there's 19 of them, what percentage of those prefer to study at home? So those that prefer to study at home is 15 of them. So for part B, we're going to have 15 out of 19 multiplied by 100%. And my calculator tells me that's approximately 78.9%. So just to emphasize that again, what percentage of business students? So we're only talking about business students here. We would divide by 19 and not 50, the total. Okay, jumping on to part C, what percentage of students? Again, you can see it's telling us what to divide by. The percentage of students who prefer studying at home, okay, so that's our key there, of the students who prefer studying at home, what percentage of them are business students? Okay, so of those who prefer studying at home, now there's 32 of those in total, so that's going to be our denominator. The ones that that are business students, there's 15 of those. So 15 divided by 32 times 100%, and that is around about 46.9%. So a completely different value to part B. So notice, even though we were talking about business students and preferring to study at home, the order in which they're spoken about, or the one which is the percentage of that we're taking, tells us what we need to divide by, and whether we need to divide by a value from the bottom marginal frequencies, the column marginal frequencies, or the row marginal frequencies. Okay, so there we are. That's a quick intro to two-way tables. We've talked a little bit about what they are, essentially just a frequency table, but for two variables, and looked at what we can do with them, how to construct them, and an example of working through that.